Hey there, in this video I'm going to talk about pressure in liquid. So to get started, we know that the formula of pressure in liquid, it is going to be P equals to rho Hg. So the rho, it is going to be our density in liquid, and the H, it is going to be our depth, which is how deep it is, and the G, it is going to be our gravitational acceleration or gravity pull. Okay, but sometimes I will prefer write in rho dg, which is the d, it is going to be our depth, because sometimes I might get confused between this h and this d. I will think this is our height, but it is fundamentally wrong. It is not height, it is depth. Okay, so let me just erase this first. I will put this, I will adjust this a little bit. And let's say this is our swimming pool, and this is our liquid, which is our water. The characteristics of this pressure in liquid, it is pressure in liquid, pressure acts in all direction like this. Pressure acts in all direction. Okay, pressure acts in all direction. If you put an object here, let's say if you put an object here, the pressure, it is going to push this object too. Okay, so pressure acts in all direction. So let me just erase this first. I will just erase this. And the characteristics of pressure in liquid, it is pressure acts in all direction. And the next one, it is going to be pressure increases with depth. Okay, which means how deep it is, the deepness of it. Which means if this is our swimming pool and the liquid, this is the liquid, the pressure increases with depth, which means this point will have greater pressure than this point. Okay, greater pressure, which is PA. Pressure stands for, PA stands for pressure. And moreover, pressure in liquid depends on the density of the liquid. Which means if you look at this formula, if you increase in density, let's say the depth and the gravitational acceleration, it is constant. If you increase the density, you will increase in pressure as well, in this case. So if you increase in density, you will increase in pressure as well. And on the other hand, pressure in liquid doesn't depend on shape. If you put 1 meter cube of water into this triangular bottle, the water, it will be triangular as well in this triangular bottle. If you put it in a round shape, your liquid, it is going to be round shape as well. So pressure doesn't depend on shape. So let me just erase this first, and let's try a couple of examples so that you could have better understanding on this pressure in liquid. So let's say this will be our swimming pool, and this will be our liquid, and the density of this liquid, let's say it is going to be 1 kg per meter cube. And let's say we have an object right here and red object right here. and the depth, it is going to be 2 meters. The depth, it is going to be 2 meters, and by this information, I can find the pressure in liquid. So P equals to the density, which is going to be the rho times 1 times the depth, it is going to be 2 times the gravitational acceleration on our Earth, it is going to be 10. So 1 times 2, 2 times 10, it is going to be 20 Pascal. Okay, and the next one, I'm going to show you how to convert the pressure in solid, the formula, to pressure in liquid. So we know that pressure in solid, it is P equals to F over A, right? And we can change it to this pressure in liquid, which means that P equals to force, so MA over this area, and we can still convert this, and we can still further expand this mass, which is density equals to mass over volume, which is density equals to mass over volume. So density times volume is equals to mass. So we can just put it in d times v times gravitational acceleration and our area. Okay, so we can further break this down into density times area times height, because area times height, it is going to be our volume, and times the gravitational acceleration, and this will be our A. So I will just, so as you can see right here, our denominator, it has A, and our numerator has the A as well, which is the area. So A over A, we can just cancel it out, which is going to be DHA. At the same time, the height, it is going to be our depth. So in this case, I'm going to change the D right here. As you can see, the D right here, I'm going to change it to rho and H. And our A, which is our gravitational acceleration, I'm going to put it as G. See, as you can see right here, I've converted the formula for pressure in solid to pressure in liquid. Okay, so basically you can play with the formula like this. So the best part is try to explore more formulas like this, and you can break it down like this, d times v, and you will know. And that's it for this video. I will see you in the next one. Bye.